this project, there are a total of 5 steps. In step 1, we'll need the following hardware: a 2100 by 300 millimeter aluminum profile extrusion, a NEMA 23 dual shaft stepper motor, a NEMA 23 stepper motor mount bracket, the left side 3D printed enclosure holder, 6 M4 slot T-nuts, 4 M4 nuts, 4 M4 by 12 millimeter hex roundhead screws, and 6 M4 by 8 millimeter hex roundhead screws. The position of the mount bracket on the 2100 by 300 millimeter aluminum profile extrusion is approximately 55 millimeters from the right and 18 millimeters from the bottom. The exact dimensions don't need to be perfect, but installing the mount bracket close to this position is important, as it will make the next step much easier. I use a pencil to mark the position on the extrusion, then apply masking tape to label the 55 millimeter side. Next, I draw an 18 millimeter line from the bottom edge using a pencil. This makes it easier to position the motor mount bracket accurately. After installing the bracket, make sure it is aligned, parallel, and at a 90-degree angle. In step 2, we'll need the following hardware: a 3D printed bearing mount, 2 8mm pillow bearing blocks, an 8mm by 100mm linear shaft rod, 2 GT2 timing pulleys, 2 U-groove pulley wheels, a 300mm 2MGT closed loop belt, 4 M4 slot T-nuts, and 4 M4 by 35mm hex roundhead screws. The timing belt doesn't need to be too tight. It should be able to move freely and stay as close to the center as possible. In step 3, we'll need the following hardware: 2 bicycle chain tensioners, 2 M5 by 35 by 20 bearing rubber pulleys, a 3D printed tubing cut-in, 2 80 by 32 angle fixed brackets, a M5 fisheye ring, 2 2020 L-type brackets, 2 M5 and 9 spacers, 2 M6 by 10 hex socket screws, 2 M6 by 8 hex socket screws, 2 M5 by 8 hex round head screws, 2 M5 by 14 hex round head screws, 2 M6 T-nuts, 2 M6 nuts, 2 M5 T-nuts, 3 M5 nuts, a M5 washer, and a M5 spring washer. In this step, we'll start by working on the tensioners using standard bike chain tensioners. First, disassemble the bike chain tensioner. You won't need the bike chain gear for this project, so set it aside. By inserting the spring pin into different holes, you can adjust the tension strength. Use a marker to mark the hole where you want to insert the spring pin. Reassemble the tensioner with the spring pin in the marked hole. Next, install the rubber pulley in place of the bike chain gear. Once you're done, repeat the same steps for the second bike chain tensioner. You'll need 2 tensioners for this project. Attach the M5 fisheye ring to the angle fixed bracket using an M5 spring washer and M5 nut. Tighten securely, then set it aside for now. For the tensioner assembly, place the spacer in position, then insert and tighten the M5 hex roundhead screw into the 2020 L-type bracket. Once installed, make sure the rubber pulley is aligned vertically with the U-groove pulley wheel, or slightly offset to the left. In step 4, we'll need the following hardware: a 3D printed slider mount, a 3D printed knife holder, a 3D printed tubing cutout, an 80 by 32 angle fixed bracket, an M3 linkage servo rod, an 18mm snap-off knife blade, a 46 by 16 connect plate, an MGN 12H linear rail slider 100mm in length, an 80kg servo motor, 2 M6 by 10 hex socket screws, 1 M6 by 8 hex socket screw, 1 M6 T-nut, 2 M6 nuts, 4 M5 T-nuts, 7 M5 nuts, 4 M5 by 25 hex roundhead screws, 7 M5 by 8 hex roundhead screws, 5 M3 nuts, 1 M3 by 18 hex roundhead screw, 4 M3 by 10 hex roundhead screws, 4 M3 by 6 hex roundhead screws, 1 M3 spring washer. First, attach the M3 linkage servo rod to the 3D printed knife holder using an M3X18 hex round head screw, an M3 spring washer, and an M3 nut. Tighten securely. Use an M5X8 hex socket screw and an M5 nut to hold the snap-off knife blade in place. Do not fully tighten it, Leave it slightly loose so we can adjust the blade position later. Be careful when handling the knife blade. It's sharp. Avoid cutting yourself. Next, attach the 46x16 connect plate to the knife holder using M5 nuts and M5x14 hex round head screws. After mounting the servo motor onto the slider mount, position it on the base. Adjust the knife blade so it is as close as possible to the 3D printed tubing. Cut in, while still allowing it to move freely up and down. Place the tubing cutout piece in position. The gap between the tubing cutout and the knife blade should be about 2 millimeters. Allowing the blade to move up and down smoothly. The edge of the knife is sharp. Temporarily wrap it with masking tape for safety. This is the final step. In step 5, we'll need the following hardware: the 3D printed enclosure, 2 3D printed profile end caps, a 3D printed enclosure holder right, an AC to DC 24 volts 3A power adapter, a TB 6600 stepper motor driver, a power regulator and wire connector PCB, an Arduino Nano, a 0.96-inch OLED display, a rotary encoder, 12 8cm AR guard wires, 9 10cm female-to-female breadboard wires, an 18T servo arm, 2 M for nuts, 2 M for T-nuts, 4 M4 8 hex round herd screws, 4 M1.7 by 3 Phillip round herd screws, 8 M2.6 by 5 Phillip round herd screws, 4 M2.6 by 12 Phillip round herd screws, 4 M5 plastic expansion tubes, 4 M4 self-tapping screws. In the Arduino code, the stepper motor is set to 1600 steps per revolution. based on the TB6600 stepper motor driver. Set the dip switches S1 to S6 on the side to this position. Off, on, off, 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 on. Connect 12 8cm wires to the TB6600 terminals. Place the TB6600 into the enclosure and secure it using 2 sets of M4x8 screws and nuts. Next, mount the PCB using 4 M2.6x5 screws. Finally, connect the 12 8cm wires from the TB6600 to the PCB. Make sure each wire matches the labels on both the TB6600 and the PCB. Connect the stepper motor wires to the PCB. Make sure the wire colors match the labels on the PCB. For the stepper motor I'm using, the connections are blue to B-, yellow to B+, green to A-, and red to A+. Next, connect the servo motor wires to the PCB. A reminder, again, make sure the wire colors match the labels on the PCB. For my servo motor, the connections are ground to ground, red to DC, and orange to signal. Match the labels on the OLED display and rotary encoder with the labels on the PCB. Then connect them using female-to-female jumper wires. Now, install the servo arm to the linkage servo rod. Before doing this, we need to power on the system. When powered on, the program automatically initializes the servo and raises the servo arm to its highest position. At that point, attach the servo arm to the linkage using an M3 by 18 hex round head screw. This screw isn't listed in the hardware list for this step. Make sure to push the sliding knife holder all the way to the top before securing the arm. The tubing I'm using has a 10mm outer diameter and 1mm wall thickness. Because the tubing is flexible and stretchable, when the U-groove pulleys pull the tubing, it can stretch unevenly. So we need to cut a test piece to check the accuracy of the length. Let's do a test cut at 5 centimeters in length. Measure it afterward. It's 2 millimeters short. That means we need to fine-tune the accuracy. Go back to the main menu by clicking the long gauge button at the bottom left corner to open the settings menu. Now look for the accuracy setting. You can adjust the number between 1 and 255. Every step of 1 changes the length by 0.1 millimeters. All right, now let's try cutting 3 pieces of tubing, each 5 centimeters long. Go back to the main menu and set the length to 5, the unit to cm, and the quantity to 3. We'll leave the speed at 10. Now press Start to begin cutting.